So hello bhai or beno. I hope you all are safe and happy. So this is the second part for the IRC code 37 video. The link for the first part is shown above. So now let's start with this video. So the next criteria.
Next important thing, performance criteria. So in that, the first one is the subgrade rutting criteria. So in this, they have mentioned that the average rut depth of 20 mm or more measured along the wheel path is considered as a failure rutting condition. So while moving along the road, if suppose this is the initial condition of the pavement, and after the various repetitions, usually we observe this kind of rutting. If suppose this is the tire of the vehicle, so we can observe the depression kind of thing along the longitudinal direction of the carriageway. So this depth that you can see here in the figure, it should not be more than 20%. If that depth is greater than 20%, then we can say that the pavement has been failed in the rutting. Let's have a look to the equations. Two equations have been mentioned here, where 80% reliability and 90% reliability has been mentioned here. This equation is used for calculating the number of repetitions allowed on a particular designed road. So the number of standard axles that the road or the pavement that we are going to design can bear, so that the depth of rut will be less than 20 mm. So this is what this equation gives to us. This NR term represent the subgrade rutting life, that is cumulative equivalent number of 80 kN standard axle loads, and the epsilon V that gives the vertical compressive strain at the top of the subgrade. As we have already discussed in the last figure, that we have two criteria. One is the vertical compressive strain at the top of the subgrade, and another is the horizontal tensile stress at the bottom of the bituminous layer. So now the rating criteria deals with the vertical compressive strain at the top of the subgrade. And what does this criteria tells that how many repetitions should be allowed on that particular road, so that the vertical compressive strain will be less. So this epsilon V, this value is calculated by using the IIT PAVE software. In this PDF of IRC 37 2018, we can also to know that what is IIT PAVE software. So this is the software which is used for the computation of the stresses and strains and deflection in the pavement, so that using this strain value we can calculate the number of allowable repetitions, so that our pavement will not fail. I hope you understood all the things. So now let's talk about this 80% and 90% reliability. If we calculate the number of repetitions allowed by using the first equation, these reliability equations 80% and 90% are used for the major roads and the minor roads. Since in this paragraph we have studied about the subgrade rating criteria, that is the 20 mm is the limiting value, or we can say the threshold limit of the depth of the rut. So now let's move to the next point, which talks about the fatigue criteria for the bituminous layer. So here what they are saying, that the occurrence of fatigue cracking whose total area in section of road under consideration is 20% or more than the paved area of the section is considered to be the critical failure condition. So what they are saying, that if suppose this is the stretch of road, and if there are some crackings, okay, there are some crackings present in the road, so the area of this all cracking with respect to the area of the total pavement, if the area of this cracking is more than the 20% of the paved road, then we are saying that that particular pavement has been failed in fatigue cracking. And if the area of cracks is less than the 20%, then we can conclude that this pavement has been not failed in the fatigue cracking. So as we have seen the two equations for the 80% and 90% reliability in the rating, here also we have the two equations. So here whatever the parameters are mentioned in the equation, their descriptions have been mentioned, you can refer to that. So now let's move to the next point. Okay, point 3.7, reliability. So as we already discussed that there were two reliability equations, one for the 80% and one for the 90%. So why there were two equations? So here we have the answer now. The guidelines recommend that 90% reliability performance equation are used for the all important roads such as expressways, national highways, state highways, urban roads, and 90% reliability is recommended for the design traffic of 20 MSA or more, and 80% reliability traffic is used for the traffic less than 20 MSA. So in short, this 80% reliability equation is used for the traffic less than 20 MSA, and this equation for the reliability, this equation of 90% reliability is used for the traffic greater than the 20 MSA. So this is why the two equations have been separately given to maintain the cost to benefit ratio. So in the next point they have said that the analysis of the flexible pavement. So as I have already mentioned, there is one software named IIT Pave which is used for the analysis of the flexible pavement. So we'll also see what is the software interface and how the values has to be given in the subsequent video. So for now let's move to the next point. So here, as we have already discussed, this is the vehicular representation. These are the two wheels of the particular vehicle. Here you can see the pavement section with the bituminous layer, granular GSB, showing the location of critical strain. We already discussed that there were the two critical things. The first one is the vertical strain on the subgrade, which is used for the rutting purpose. Second one is the tensile strain at the bottom of bituminous layer. So this one is used for the cracking purpose. These two are the parameters on which our whole pavement design is based on. Similarly, the pavement section with the bituminous layers, granular crack relief layer, CTB and CTSB showing the locations of the critical strain. So if the CTB and CTSB has been included in our pavement layer profile, then what are the critical strain or the position of the strain that we must consider has been mentioned here. Similarly, you can refer to all the figures and the position of the strains according to the layers that you have provided to your bituminous pavement. So now,
So the next topic, that is traffic. So this topic will be discussed in the next video of this IRC 37. So till then, stay safe, stay happy. Thank you.